Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to answer the burning question on everyone's mind these days: what is a centripetal force? So we're going to start this discussion over here with this simulation I have of this ladybug here. And I'm going to go ahead and turn the simulation on. So we have this ladybug, pretty fast ladybug, who's walking along this circular path here. Now, the next thing I'm going to do is put the velocity vector on that ladybug. So there's the velocity vector, and an important thing to realize about this vector, it's not changing in length, meaning that the speed of that ladybug is not changing. However, what is changing is the direction. You'll notice as this ladybug moves in a circular path, the velocity vector changes direction. And a very relevant concept here now is the idea of centripetal acceleration. So hopefully you've seen my video about centripetal acceleration. Centripetal acceleration is the acceleration which has to do with the changes in the direction of this velocity vector. Now if I actually put an acceleration vector on this as well, you'll notice that points inward. Now, let me put them both on here. So the velocity vector is pointing tangent to the curve at all points, and the acceleration vector is pointing inward. Now the reason this points entirely inward towards the center of curvature is because the ladybug is not speeding up or slowing down. If the ladybug did that, there'd be acceleration components parallel to this velocity vector, but I'm going to just limit this discussion for just uniform circular motion. So the acceleration of this ladybug is completely inward towards the center, and it's a centripetal acceleration. All right, now we're going to go over to this picture right here. I've done my best to kind of reproduce a picture of this. And I took a little snapshot here at this instant in time, and I'll try to get this stopped right there. That's close enough. So here's kind of a snapshot of what's happening here. Now, we're going to kind of do a quick little review of Newton's laws of motion. Newton's first law of motion is that an object's velocity will stay constant until you have a net force that's not equal to zero. So at the instant shown, if the net force on this ladybug were zero, there'd be no change in velocity of any kind, magnitude or direction, and that ladybug would move along this straight, or what I call linear path here. So this green path would represent what would be happening if the net force were zero. The ladybug would move along the green path, parallel to this velocity vector. Net force would be zero, velocity would be constant. Now, we can observe, though, from our simulation, that's not what's happening. The ladybug is moving along this circular path. So by Newton's first law, there has to be a net force on that ladybug. Right? Now, by Newton's second law, remember, is net force is equal to ma. This ladybug is accelerating inward, as seen by this acceleration vector. So there has to be a force inward acting on this ladybug. Now, that force, in all likelihood, if this ladybug were walking along, would be maybe a frictional force. Or perhaps this ladybug is on some sort of like record player moving in a circle. Again, that would be a centripetal force. Or maybe a less popular example, perhaps this ladybug has a tack through it, or is glued down, but still on a turntable going around and around, right? Then this would be some other force. So what the nature of this is right now is not important for the discussion. The important thing is that this is the force, whatever it is, that's changing this path from linear to circular. Now, to answer this question, what is a centripetal force? Well, there's a couple ways to answer that. Here's one answer. It's any force that results in a centripetal acceleration. All right, another possible answer. It's forces that are at a right angle to your velocity vector, which cause the velocity vector to change direction. So that's what a centripetal force is, and if we apply Newton's second law, by the way, which says the sum of all forces is equal to mass times acceleration, and if we apply that in this direction, we have that whatever this force is equal to m A, where that acceleration is a centripetal acceleration, and hopefully you see my video on how to calculate that. Centripetal accelerations are calculated by taking speed squared divided by the distance. So I like to think of centripetal force as any force responsible for one of these types of accelerations. A centripetal acceleration equal to v squared over r, which changes the velocity vector's direction. Centripetal accelerations are always pointed towards the center of curvature, as are centripetal forces. Now, a centripetal force is not a new force. It's not like, it's not something, if you're good at drawing free bodies, you're not going to be trying to put centripetal forces in. You just put your forces in your free bodies as you normally would. And then whichever those forces, they could be normals, they could be frictions, they could be tensions, they could be gravitational forces, they could be other types of forces. If they are causing a circular motion effect, then they would be classified as a centripetal force. So I think I'm going to leave that off right there. Call that good enough for this particular video. The point of this video was what is a centripetal force? Hopefully I've answered that. It's any force that's responsible for this type of acceleration, an inward type of acceleration or a centripetal acceleration. So everybody have a great day.